All right then, hello everyone. This is Volts for March 14th, 2025. Making sure smart devices can talk to each other and the grid. I'm your host, David Roberts. America's homes are about to be invaded by a wave of smart products intended to coordinate energy use. Your thermometer, EV charger, solar panels, battery, water heater, stove, they're all going to be communicating with one another and with the grid, harmonizing their operations for maximum efficiency. Or at least, that's the vision, which is sometimes presented as a kind of frictionless Eden. But what if you buy your smart devices from a company that subsequently goes out of business and takes its proprietary software with it? Do the devices just get dumb? Do they work at all? Or what if your HVAC and your EV charger each run their own proprietary software? Will they talk with one another? How is all this stuff supposed to work together, especially in a chaotic and fast-growing market with startups coming and going like fireworks? In response to concerns like these, more than 24 big energy utilities, manufacturers, and tech companies have formed the Mercury Consortium. The idea is to come together around a common set of interconnection protocols and standards that will ensure that all these devices work together and with the grid. The inspiration is Bluetooth, a common protocol that grew out of a voluntary industry initiative. The consortium is the brainchild of Devrim Celal, the Chief Marketing and Flexibility Officer at Kraken Energy. I'm excited to talk to him about how it's going to work, when we can expect a new standard, how to future-proof these things, and the question of privacy. All right then. With no further ado, Devrim Celal, welcome to Volts. Thank you so much for coming.
Thank you, David. It's a pleasure to be here.
I'm excited to talk to you. I want to kind of start before we even get to the standards thing, because I bet a lot of listeners share my sort of vague cloud of confusion, or at least the confusion I had before I started reading up about this episode, about exactly what Octopus and Kraken are. So let me put it to you and tell me if I'm getting it right. So Octopus started as a retail utility in the UK, where they have retail utility competition. It grew and grew, became the biggest, I think, retail utility in the UK. And then the software system, the platform it used to run its utilities, to coordinate devices, to do customer service, etc., it spun that off into its own product called Kraken, which it is now licensing to other utilities so that they can unify these out-of-date, clunky, old, separate systems into a single unified system that allows them to do customer service and manage distributed energy, resources, and all these other things. That's Kraken. That's Octopus and Kraken. Are there other pieces of that, of the octopus beast, that I'm missing?
So that is a great description of it. But within Octopus, we actually have this story that a debate on what came first. And it was actually, Kraken was the first. The idea was to build software that can positively disrupt the energy sector. Mm-hmm. And when the founders of Octopus Energy Group spoke to utilities, they either said, "Oh, that's a great idea," or "Thank you, we've got this covered, go away." But even those who said this is a great idea, they often ended by saying, "Let's see how others react." Right. And it became quite apparent early days that in a very conservative industry, and for good reasons, in a conservative industry like the energy industry, utilities act with caution. So it was imperative that we build our own, as you described, energy retailer in a competitive market to demonstrate the capabilities of Kraken, to show how successful a utility can be using this before we can sign the first big utility, which was E.ON, the German original national supplier. And then many came since then in the last 5 years.
Got it. And so I think when we chatted before, you said there were at least one or two other major divisions of Octopus, and afterwards I couldn't think of what they were. Can you just quickly tell me what those are? It's such a huge affair.
So our group structure is quite thin. Don't think of a big corporate. And underneath that, we have four distinct business areas. Electricity retail is the first one, and that's under the Octopus Energy brand, active in 8 regions around the world, including Texas. Today, with just over 9 million customers globally, as you noted, the largest in the UK across all energy, and with some incredible customer satisfaction ratings. In Europe, we measure customer satisfaction by an agency called Trustpilot, where 5 stars is the highest. Octopus entities usually get between 4.8 to 5 stars. Our second business unit, which is quite nicely juxtapositioned to electricity retail, which is all green electricity. So the second business is our fund management business, where we raise money in private and public placement and then deploy that capital either to develop or acquire solar, onshore, offshore wind and storage projects and operate that asset through its life.
So you have a whole power development business.
Exactly. A whole team that raises money to develop renewable projects and then competitively sells the generation of that to markets where Octopus Energy participates and procures a significant chunk of that at competitive rates.
Right.
Because at the end of the day, it's other people's money that we use to develop those projects with. The third domain, broadly called Octopus Energy Services, to me is what exemplifies the mission of Octopus, which is using technology to accelerate the transition and enable access for masses to cheaper and greener electricity. And when you give that statement, you realize there are some big gaps. And the first gap was to do proper optimization of the system, you need smart meters that give you real-time data of what consumption is. Now, in the UK, that was a regulatory responsibility for a retailer to do. So we built a smart meter installation business, which rapidly expanded into installing all the devices that you mentioned at the beginning, charge points, solar on the roof, batteries, heat pumps. But then you realize as you move through that journey, there are bigger gaps. And the first obvious one is electrification of transportation. When people buy an electric vehicle, you have to appreciate it's the first time they buy it. Up to that point, they've been buying something completely different that consumed gas and had a combustion engine and needed servicing regularly, needed oil in its engine. And now they buy this thing that runs on electricity, which they can charge at home. So we realized that rapidly that needed a very different end-to-end experience and set up Octopus Electric Vehicles to sell cars.
Oh, interesting.
Yes, it started in the UK and it's one of the largest electric vehicle leasing businesses in the country today. And it's been driven by the power of the brand of Octopus, but also the user experience of giving them a tool to educate them to make that buying decision easier.
Interesting. And that's just in the UK for now?
UK, Germany, and Texas.
Texas.
And looking to grow in North America. And the last point in Octopus Energy Services was electrification of heating. In most of the world, heating is gas-based. Heating in general is one of the biggest pollutants. So electrifying that required heat pumps, and heat pumps, unfortunately, were not economical. To give you an example, it costs somewhere between $16,000 to $20,000 to install a heat pump to a home in the UK. That number varies a little bit by region, but not by much, which pretty much says that it's only going to be a small part of the population that would choose to install a heat pump as opposed to a gas-fired boiler. So we looked at that and said the problem here is much bigger. We need to optimize how heat pumps are built, installed, and managed. And the only solution to that was to go and build one from scratch. And that's what we did. We acquired a heat pump manufacturer in Northern Ireland called RED, Renewable Energy Devices, worked with that team to redesign a heat pump from scratch, improved the form factor so it was more efficient, but managed to reduce the cost of manufacturing to the point today that with a government grant, we can challenge gas-fired boilers in economics significantly. And that product is now taking off. We're selling heat pumps faster than we can manufacture them.
Oh, interesting. And is that also in those multiple markets, or are you just starting in the UK with that one?
So today in the UK, we sell our own heat pump called Cozy 6 and Cozy 10 as 6 kilowatts and 10 kilowatts.
I've seen pictures. They're very cute.
And they look different, right? It's an appreciation of it's garden furniture. It needs to look good,
Yeah.
as opposed to usual white cubic boxes that you would get.
Yeah.
And that's a function of how manufacturing of heat pumps started. It was corporations that designed and manufactured large-scale heating, ventilation, and air conditioning systems that had this as a side business that needed to come from a similar industrial production line. So they look like air conditioning units.
Right.
So that's why the heat pump looks different. It looks better, and it's cylindrical, which is supposed to have much better thermal properties. We sell Cozies only in the UK. We also sell other heat pumps in the UK. Cozy isn't a heat pump for every consumer use case. We sell them in Germany, and now we're looking to expand that business elsewhere as well.
It's like Octopus set out to electrify things and kept just like discovering like, oh, it looks like we got to do this too. Looks like we got to do this too. Fine, we'll just do all of it.
Well, if you look at the mission, if you start with the mission, we've always been true to that mission, and we keep finding other things we need to do to achieve it. And Kraken fits nice that story because everything I've just described runs on Kraken, whether it's helping a utility, its relationship with the consumer, billing, meter data management, all the forms of interaction, whether it's an app, web, or a call, whether it's helping large generation managers manage their assets better so they get much better economics from them, or it's for utilities to give their consumers special tariffs that incorporate managing the charging of their EVs or their batteries or their use of their heat pumps.
Right. And so the software, like, it's not like utilities couldn't do that before, but it would have just been difficult to coordinate, difficult managerially, and the software makes it easier, is the idea.
Exactly. So before Kraken, a utility would have dozens of systems to be able to do the things they do every day, from sending bills out, answering calls, resolving issues, collecting debt, or building demand response programs to manage charging of EVs of their consumers. With Kraken, all of that, as well as monitoring the distribution grid, comes into one place, which makes it a lot easier to optimize behavior at a holistic level, but also reward consumers to participate. Because I can tell to a consumer, let the utility decide when is it the best time to charge your car, for as long as it's ready when you need it. And for that, we'll give you a 50% discount on your charging. That's a simple proposition to the customer. It says, I will get cheap range as a result of that. Whereas utility gets to better manage its generation assets, its networks, its engagement with the consumer.
From the consumer point of view, you just have this sort of portal. Your utility gives you this portal, and you go and you say, here's my water heater, right? Here's my car. Here are the things I have. Here are my baseline needs. Like I need the car to be fully charged by 8 a.m. I want a minimum of 68 degrees temperature in my house, et cetera. And then it's just off and running for that. It just optimizes your energy use based on what you have and what you need. But after that, you don't have to mess with it.
And I'll give you a statistic on that. You don't have to mess with it one. 80% of EV owners will say, charge my car up to 80% state of charge by 7 a.m. tomorrow morning. 80% will never touch it again.
Yeah, that's funny. We need to get to the standards. I'm just sort of fascinated by Octopus. It's such an apt name for.
Yeah, and to close the Kraken story, and this is the part I was building towards. If you were Coca-Cola, which allegedly has the formula for Coca-Cola locked up in a vault in Atlanta, Octopus should have locked up Kraken and said, I'm not showing this to anyone.
Yeah.
Because that's my competitive advantage. Whereas if the mission is a bigger one, you don't behave that way. You say, I will not only license Kraken to my competitors, but I would actually train them, help them transform their businesses to the same operating model that's made Octopus such a success, so they can replicate exactly the same thing, both in my countries, but elsewhere as well.
So for utilities, this is software as a service. So they're basically leasing, kind of renting the software from you, and you're helping them, you're helping to train them and customer service, all that kind of stuff.
And it's actually beyond training, it's full transformation. Because if you look at a typical utility structure, you would have departments for billing, onboarding, issue resolution. They all have their own systems. And when you call a utility initially, you might get transferred once or twice until you can resolve an issue. What we do with Kraken, it's a transformation project where we create a new organization from the old one, where the model is what we call a universal agent. So any customer service rep will be able to pick up any call and resolve it on the spot. No exceptions, no back office, no pass-throughs. In fact, I say this jokingly, but it's actually true. Octopus energy specialists or customer service reps on their phones don't have transfer buttons because they should be solved issues that come to them. And what that does is it increases your customer satisfaction rating significantly because things get resolved. It helps you run a much more effective system. The cost to serve goes down by 40-50%. But then here's the metric that I love. It gives you the highest employee satisfaction ratings because if people are autonomous, enabled to perform well, they're happier.
Yes, people like to have agency and feel competent. And yeah. Well, let's get to the standards because that's what this pod is about. So all of that background is by way of saying that Kraken, the software platform, is already managing millions of distributed devices. So you were sort of the CEO of the Kraken Connect before you became in your current position. I know you've been involved with Kraken for a long time. So maybe tell us a little bit of the history about how you ran up against this question of standards and what the need is.
So I'll take a step back and give the background at once. So my business was called Upside Energy. And we had built Upside Energy to be able to control and optimize millions of consumer devices so that the energy system could continue incorporating more renewables and not have to constantly upgrade the distribution infrastructure to manage that change in behavior.
Right. These are virtual power plants. It's what they're called.
Yes, in a matter of speaking. Virtual power plants terms, people use different terminologies for it to describe different parts. Then in 2020, Octopus Energy acquired Upside Energy to become the Kraken Flex arm of Kraken. Kraken's consumer information system, CRM, billing, meter data management capabilities were already in-house what Octopus Energy Group had built. And Kraken Flex was originally a separate entity. Today, we are singular. It's one Kraken to the outside, the operating system, with multiple applications that also allow interoperability. So if a utility says, we want to have Kraken customer, but we have our own VPP providers, DERMS providers, they can access Kraken customer in exactly the same way our flexibility products like SmartFlex, InfraFlex access it. So it's an open system. It's actually an open ecosystem. It's not, we have to verify and ratify people who connect to it, but it's an open system as our customers come to us and say, here's our favorite players I want you to work with. But that's sort of been built out to it. And today, to give you the exact numbers, we manage close to 400,000 devices in real time. That's about 1.6 gigawatts of power that can be turned up or down at any moment in time and space. And that's where consumer devices become really powerful. Because if I have a network constraint in a certain part of my system, I can pinpoint the devices there now to change behavior to alleviate that congestion. If I have a system-wide energy problem, like I want to use more renewables, I can orient charging and behavior to maximize that and move myself away from needing to run gas generation, for example.
Yes, and it's faster and more precise, I think, than gas generation. Anyway, it's a better product.
And that's the interesting one, and mildly controversial, even though it doesn't need to be.
I know. A lot of people are stewing that I said that.
Big gas generation is a single point of failure. 400,000 consumer devices statistically is a lot more reliable because I can predict behavior. I can predict when people will get home, what will be the state of charge in their cars, what will they ask us to do for them. Typically 24 hours ahead with over 90% accuracy systemically. So that's a very reliable tool to help me manage my system.
And these are mostly today, anyway.
Yes.
Mostly cars and thermostats. Is that the bulk of what you've got connected?
It varies by region. So in UK, it's predominantly cars. In Texas, it's a mixture of cars, batteries, thermostats.
Interesting.
Germany, it's cars, batteries. Germany has a large residential battery penetration. Japan, we're looking at a lot of air conditioning load and then batteries. So it varies a little bit by the geography. The key to Kraken is we have all these devices pre-connected, And I think that's where we're going to come to standards. And we allow the utility the ability to say, hey, I want to pick these devices, design this kind of product or tariff, and this is how I want to build my user journey so I can attract my customers to sign up to this, register their devices. So I create flexibility from those devices as opposed to constantly building my infrastructure to manage the new peaks that they're creating on my system.
Right. Managing demand rather than managing supply, rather than adding supply.
Correct.
So then, have you actually, in practice, run into a problem of devices having different software and different standards, or is this mostly something you are trying to head off before it happens?
So we've been doing this since 2016. Today, we have a team of 70 software engineers in Manchester, United Kingdom, and in Texas, Houston, and some in Japan, some in Australia, whose job is to integrate new devices that our customers ask us to have as part of their portfolio. I used to say we have about 50 different makes and models integrated, but recently one of our clients said, could we actually get an Excel spreadsheet that shows us everything on it as we're building our products against this? And I asked the team to give me their Excel spreadsheet of what's been integrated, and the list was now nearing to 250 integrations.
So every new make and model of an appliance is its own little software project? Like each one is a bespoke integration project?
Sometimes multiple integration projects. Because what happens is it could be a year of manufacturing. So when you are registering a EV with a utility that uses Kraken, you would get a drop down. What's your EV make and model? And you'll choose it, and you'll press a drop down and say, I've got this model. Then you'll probably have to choose which year it was manufactured in. Now that sounds quite detailed, but the communication could change, the behavior could change by year of manufacture. For example, I just gave one.
That's crazy.
Yeah. And that forces us to have multiple integrations for each OEM in some cases. But then you have other things that make it easier on the surface, like OEMs starting to use certain protocols, like one for EV charging is Open Charge Point Protocol, which gives you a framework, it's a protocol, but then there are slight nuances on how you interpret it and implement it as a OEM, a manufacturer, and how Kraken may have interpreted. So then you have to work to figure out how to get the two interpretations of a certain protocol to work together. Naturally, that reduces the amount of work, but it doesn't make it a given that just because you both implement the same protocol, that it's going to work seamlessly on day one.
I guess I don't know what I envisioned, but that's much more manual than I imagined. Like that's a brute force kind of thing.
It's manual to do it the first time. Some of the other things we come across is you expect certain behaviors. For example, if I'm connecting to a inverter that manages my solar, but also helps push energy in and out of my battery, what we call a hybrid inverter, I would expect it to be able to tell it, if your solar is generating now, I want you to pass 2 kilowatts that off to the grid, 1 to the battery, and the rest of it leave it for the home load, for example.
Right.
It's rarely that we get that depth of control. It would be typically preset conditions that says maximize battery first, then home, maximize home load, or export all of it to the grid. So it's these nuances that we look for to allow us much more granular control so that we can tell to the grid operator, no surprises. We can get this device to do exactly what you need it to do, so you can allow it to be installed without having to upgrade the network so that we get rid of those planning bottlenecks that we're starting to experience at scale.
And so is the idea here to move a little bit of this onus onto manufacturers so that the products they're making by default plug in to your system rather than you having to do a special software project for each new model? Is that what you're pushing for?
So the ambition of Mercury, the objectives are, there are a number of them. The first one is exactly that, is to say to, and by the way, we're working with the biggest manufacturers of EVs, batteries, heat pumps in the world on this one. And this wasn't a pull. They were all very interested in this because they see this as a way of unlocking some of the friction, but also building consumer trust. So consumers, as you described, if my startup goes out of business, will I be able to use my battery, continue making a return from my battery?
Well, can I insert a question here? Because I actually had a question about the motivations of the people involved. So I can understand the appeal of interoperability to a manufacturer, but I can also see a manufacturer wanting to build a walled garden. You know what I mean? Like not like wanting to trap people and not make it easier for people to get out. I mean, we see this kind of stuff going on in software all the time, all around us, right? I mean, the software, the platform operators try every way they can to trap you and make it difficult for you to leave. So clearly that's a motivation too. Did you not run into any of that? Did you not run into any sort of resistance or anybody who's like, I don't want to be part of an open system. I want to trap people in my garden. Did you not encounter any of that?
I would say so far no, but we're early days, and people that we reached out to who said, yes, we want to be part of this, or who came to us proactively, are obviously people who see the need and the benefit of Mercury. So far not. I expect that we would get to that point, get there at some point. But then again, the real thing we're trying to solve for here is, and the metric I'm going to share is controversial, but whichever way you look at it, it's important. I say about 5% globally, 5% of consumer devices that can support the grid actually do. 95% don't.
Well, what do you mean by can?
So electric vehicle, heat pump, a battery should be able to take a signal, whether that's a price signal or just simply a signal, a dispatch signal saying do this, should be able to receive that, accept that, and behave in line with that grid request for some benefit to its owner. That's what I mean by that.
So that's theoretically every electrical device. I mean, theoretically every electrical device could play some small role, right?
I agree. What I paraphrase there, though, it should be, to us, our focus is every electrical device that can generate, store, or consume electricity. That's a significant load in the home. So when you get down to your cooker or your washing machine, those don't make it for me. But the heat pumps, the batteries, the thermostats, air conditioning, hot water tanks, electric hot water tanks, all of these matter.
And those 95% that could, what's required to put them into service? Is it just sort of smacking an interface on them? Like I'm always curious about this particular piece of it. Like if I have a dumb water heater, I do have a dumb water heater. What is required exactly physically to make that part of a Kraken style system where everything's working together? Am I just literally attaching some sort of electrical device to it? Like, what does that look like?
That use case wouldn't be our focus, but you could put a smart switch to it, smart socket, if that's a safe use case to do with your hot water tank, or something slightly more intelligent to give us ability to monitor it, measure the temperature, so we know which times we could switch the heater on and switch it off and know how long the heat will last in the tank. So when you get home in the evening or wake up in the morning, you have hot water to take a shower with. That's a very common use case in Australia, for example, where water heating is electric, massive numbers, and that's what a lot of utilities do. But the use case we look for is, I use the term quote unquote, smarter devices. So devices that already have communication capability built in.
I see.
That we're doing a software augmentation on top to get the functional requirements done. So be able to charge, discharge with an instruction at a granular level. Be able to take a schedule like 24 hours ahead. If you don't hear from me, I want you to do this. To be able to provide telemetry from the right points with the right level of frequency and granularity. It's all these things which, in the first instance, could be just firmware updates to provide those from these devices. So that's the first objective. The second one, Mercury objective, is to give the utility the ability to communicate with these devices and reach their functional requirements. And that's where often Mercury and standard is used in the same description. In fact, Mercury will probably never define a new standard. And that's the biggest difference between Mercury and the inspiration, Bluetooth. Bluetooth consortium kicked off by Ericsson had to define the Bluetooth standard because there wasn't anything else in place to allow consumer devices to talk to each other. Whereas in our world today, there are a lot of standards, and I can list several of them that we use actively today. And they're good standards, so there's no need for us to define them. Instead, what we'll probably be defining is guidelines to say, if you're implementing OpenADR, OCPP, here's a guideline of how we would like you to implement it, because we know this works and will create uniformity of those implementations.
So you're not asking, the standards are not for particular physical technologies. The standards are performance-based, basically. Like you get the certification if the device can do X, Y, and Z.
That's it. And we'll set testing criteria to say, we're going to run these tests to test the communication, to be able to test the ability of the device to deliver against the functional specs. And if you pass, you get to carry the Mercury logo, which gives you that ability to say, if I buy a Mercury certified battery, even if my startup goes out of business, the next one will be able to step in, a demand aggregator, for example, and perform the same service so I can continue earning an income from my battery.
Now, how far are we from that? Like, is everyone really using different standards now? Like, is this a real problem? Are a lot of devices kind of getting bricked by this? Like, what is the current state of play? Hey there, everybody. Don't worry, I'm not going to tell you about a new mattress or push a credit card on you. This isn't an ad. There are no ads on Volts. It is supported entirely by listeners like you. If you'll indulge me for a second, I'd like to ask for your support. I started Volts because we're all surrounded by depressing news about climate change and misinformation about clean energy, and it's never been more important to share the stories of the real people on the ground doing the real work of transition, and all the ingenuity and courage and public spirit they are bringing to it. People are hungry to hear these stories, to learn from and find inspiration in them. I've heard from people who changed majors or careers after hearing episodes of Volts, people using it in classrooms and community groups, even state legislators who have passed bills inspired by specific episodes. Sharing these stories matters. It makes a difference. If you have found value in it and want to help me continue doing it, I hope you will join the community of paid subscribers at volts.wtf. It's about the cost of a cup of coffee a month. If you don't like subscriptions, you can make a one-time contribution, leave a review on Apple or Spotify, or just tell a friend about Volts. I am grateful for any and all support. If you're already a paid subscriber, thank you. And now, back to the show. Is this a real problem? Are a lot of devices kind of getting bricked by this? Like, what is the current state of play?
I don't think we're at the stage. The bricking of devices would happen if we were tinkering with firmware, which we never do. That's OEM's business. They should be the only ones updating, changing firmware on their devices. And that's required for cybersecurity, personal safety, personal data. What we are seeing now is the problem that I described at the beginning, the proliferation of makes and models coming to market. Across all the product dimensions that we talked about. There is a proliferation of standards. I was in a meeting earlier today where another entity is talking about developing standards in Europe. So what Mercury is trying to put is a framework across those to make existing standards work and to give guidelines to manufacturers from the utilities to say, we like your devices to do these things so we can create value using them.
When I threw this out on social media and asked if people had questions about this, that's one of the questions I got more than any other is like, how do you avoid just making more and more standards? You have a standard piled upon standards. So you're not actually making standards. You're creating a set of functional requirements.
And testing criteria.
Such that a utility using Kraken can go to a new home, and if the home has an appliance that is Mercury certified, you can just sign that right up without having to do some sort of bespoke software project on it. Is that the idea?
Correct. And let me broaden that. Kraken is only one of the technology partners today. So that could be Oracle, it could be Lunar, it could be Enphase. There are a number of other manufacturers and tech providers, SolarEdge is another one, who would benefit from this as much as Kraken. And the manufacturer and the utility. So I think this is the founding members of Mercury are all equals who all stand to benefit and ultimately consumers who all stand to benefit from what Mercury could achieve.
So to put it more broadly, if any one company that's managing a set of devices for whatever reason disappears, with Mercury in place, any of these other companies could step in and manage those devices.
Correct.
I see. And when we talk about the sort of standards involved, are these all, how do I ask this, sort of like technical about forms of communication and capabilities? Is there anything about just like good behavior? You know what I mean? Sort of like standards of behavior in addition to technical standards?
Expand on that for me.
I barely understand what I'm asking well enough to explain it to you. But you know what I mean? Like, are there privacy standards or, things like that? Or is this purely a technical thing?
It's purely a technical and things like cybersecurity. How do you do authentication? How do you encrypt data?
Yes.
How do you manage consumer data? How do you manage consumer billing? All of those should sit in the protocols. Protocols define guidelines and ways of doing that.
Mm-hmm.
Or it could be tech providers like Kraken or any one of our peers that define those. And in this initial phase, it's not Mercury's focus because it's already solved for in different domains.
Mm-hmm. So this is all about technical interoperability, basically.
Correct. And I use interoperability quite cautiously because Mercury will not be defining how your heat pump interacts with your EV charger. It's how each individual device interacts with the grid. So it's interoperating across the grids and with the grid as opposed to with each other.
I see. But will thereby be meshed into a single system.
Correct. Or multiple systems.
And so how exactly is this, just to get a little prosaic, how exactly is this going to proceed? Is this just like all these companies are sending representatives, you're having meetings, is there going to be some official output, or is this like it's going to be an ongoing thing? What are the actual mechanics of how it works?
Full steam ahead at the moment. So EPRI is managing the process. We're just one of the participants. There are a number of committees established working on different parts of the initial puzzle. They're all equally important. The first one is setting and agreeing the charter of Mercury. So what will Mercury do? How will it be governed? What type of membership will we have? Like on Bluetooth, I believe you have two types of members, the big corporates and the rest. How will we set the testing criteria? Who will be the test centers? All of that is being defined as the charter work. We have work in the process of establishing Mercury Consortium as a not-for-profit in the US and all the legal work that goes with that. So that's one stream of work. The other stream is working with utilities to define their functional requirements. What do they need these devices to do?
Right.
And the founding member utilities supply 130 million homes around the world, from Australia, across Europe, into the USA. And the next stage would be, once we've defined those, start putting those to certify the first device category, which will be an EV charger. And the work on that is ongoing as well. So everything is leading towards a end of March initial announcement. Incorporation and finalizing things will probably take a few more weeks after that, but watch this space for announcements from early April into May.
So a Mercury certified EV charger theoretically could be on the market this year?
Yes, definitely.
Interesting. And then you're sort of going to march through products, presumably, as it goes?
Yes. And we put this to a vote. Initially, we thought it would be a battery. And at the launch event in December, we did a poll on the go in the room, and it was a battery. But then when we did a broader poll of our members, they all chose an EV charger, which I think was the right decision because it's more universal. It's a big load. It's a new peaking load with less control. It's the one that gives utilities the bigger headache than battery systems.
This is the one that I'm guessing, if you talk to utilities, the one that they're freaking out about the most.
Yes.
In the short term.
And if you think about the economics of it, it's been the cheaper car to drive for a while, but it's been the more expensive car to buy until now. And it looks like we're at the point where that economic will tip as well. So suddenly it'll become the natural choice as people buy new cars.
Yeah. Okay, I have a question. I don't want to get too geeky here because I'm just a poor English major, but I would like to hear a little bit about some of the specifics You said you're talking to utilities about what are these performance requirements? Like, what do you want these devices to be able to do? Could we just say a few words about some of the granular sort of like type of things that you're asking these devices to do? I mean, you mentioned some of them before, but could we just go through a quick list? Like, what are the sort of checklists?
I'll give you my list. I'm sure team are in a lot more detail, but leaving it at the sort of my economics background or English major at that convergent stage.
Yeah.
So the first set of criteria would be things that I need to be able to read and hear from the device.
Mm-hmm.
So I need the device to tell me what it's doing right now. And that would be, I am generating or I'm consuming so many kilowatts at this moment in time. I probably need the device to tell me what it is as well as part of that. If the device is able to, I may want it to tell me the current, frequency, temperature, where it is. And I may need that device to tell me that information at a certain frequency. Like it could be every second, it could be once a minute, once every 5 minutes. I may be able to want to configure that telemetry to say, do it every second now, but later on, overnight, for example, drop to every 5 minutes. And this could expand. It could be irradiation if it's a solar PV inverter that I'm controlling.
Mm-hmm.
So there'll be extensions of this depending on the device category. Then on the right capability, things that I want to be able to tell the device to do, it would be changes to its behavior. So if it's consuming 2 kilowatts now, it may have told me that I can change that. My ability change is this. I may ask it to do that. So I should be able to tell it to stop using that 2 kilowatts or go down to using 1 kilowatt or go down to 1 kilowatt in 1 hour's time. So giving it a schedule to do things. It will be behaviors roughly in this category with extensions to provide more depth and relevance to the technology that we're controlling.
And so all these are doable. Like technologically, none of this is a stretch at all. It's just ensuring that it's all in one place.
And harmonized.
Right. You mentioned before that this isn't really a standard. It's a kind of a coordination of standards. But, there is the question of these other efforts floating around, and I'm curious how they relate. So, for instance, there is the Connectivity Standards Alliance.
Yes.
The CSA. They have a set of smart home device standards called Matter.
Yes.
Is that different from what you're doing? Parallel? Part of? Consonant with?
Nicely positioned next to each other for collaboration. And I can add a few more. There's Clean Energy Commission Australia, who's coming up with standards for how you control solar inverters, a big headache area for them. There is the EE-Bus set out of Germany to do something quite similar and overlapping to Mercury. There's OpenADR, a communication protocol originated from the US, VHB ready. So our role is not to replicate, duplicate, contradict, but to work in harmony with existing standard and communication protocol governance bodies, so that we're getting a lot more out of what they've created and putting it into use. Similarly, in the UK, the Department for Energy, is called DESNES in our case, has got initiatives to start building standards, guidelines for these smart home devices to both be secure and able to provide grid supporting services. So we're collaborating with them. There's the British Standards Institution. Again, we're collaborating with them because one of the things that Mercury can bring is a combination of technology firms like Kraken, who move very fast, manufacturers who have a consumer mindset, and utilities who need to do something with that. We can move very fast. And that's why I confidently say we're going to have an EV charger Mercury certified very soon, and we'll have probably multiple more devices before the end of this year. And that becomes sort of the spearhead that helps inform some of the more standards that will come afterwards, or how they could be amended to make them more relevant for the use cases that we're trying to solve for.
So you don't worry about a proliferation of incommensurate standards. You think all these are going to sort of harmonize over time?
I would be worried if we didn't have a way of harmonizing them, because that would just create more fragmentation in the market, which was the problem that we've identified. My hope for Mercury is it will become the unifying entity across those, and manufacturers could say, or utilities, this is the standard that I want the devices that I'm manufacturing or that are installed in my area, and they should be Mercury certified. So that means if a utility says, I want my devices Mercury certified, that's sort of the benefit case for manufacturers. And the benefit case for a utility is they'll know exactly what they're getting from those devices.
One we didn't mention, one of your big partners in the Mercury Consortium is the Electric Power Research Institute, EPR. They also have an initiative called Flexible Interoperable Technologies, Flexit.
Flexit.
Yeah.
Yes.
Is that again, just like sort of harmonizing with what you're doing, or a subset of what you're doing, or something larger than what you're doing?
So I'm not familiar with which direction Flexit is heading, but my understanding is that's more interoperability of devices, whereas Mercury is setting those functional requirements and defining how they interoperate with the grid systems.
Got it. Interesting.
But EPRI, to give EPRI the credit that's due, has been Kraken's partner at instigating this, orchestrating and bringing a large number of the US utilities to the table to work alongside to conceive the founding team of Mercury.
And another question I got on social media, when I said that the model here is Bluetooth, a lot of people's immediate response was, Bluetooth sucked for several years. I mean, Bluetooth sort of was associated with maddening connection issues, et cetera, et cetera. And that's like, it's mostly ironed itself out now, mostly works now, but that did it a lot of damage early on. You know what I mean? Does that example ever loom in your head? Do you ever worry about that?
So we don't have the one benefit that Bluetooth had, which was they were building something, or challenge, if you will. They were building something completely new, and they did absolutely the right way. They went to market early. It was very techy. I mean, It's called the Bluetooth Special Interest Group. It started as an engineering project, and it was the absolute right way. Get something out there, get some people testing it, learn from it, and constantly iterate and improve. And that's what they've been brilliant at. Today, when you go and buy a set of headphones, you don't think if it's going to work with your mobile phone. You assume that it will. So I think today where they got to is excellent. Now, what we can't afford to do is have that bumpy start at the beginning.
Yeah. Headphones are one thing. The heat in your home is a different thing. You don't have as much patience, I think.
But fortunately, we have founding members like Kraken, Oracle, AWS, Lunar, SolarEdge, Enphase. And I'm missing a few, so please, nobody be upset with me. I think all the members are brilliant, and it's all on the website. But look, collectively, we have incredible amount of experience, and the manufacturers as well, the Renaults and Daikins of the world. And we've been working with consumers and deploying very successful, large-scale demand response programs to date. So we need to bring all that learnings and make sure whatever we design, implement, and launch from day one just simply works. Because our biggest challenge is to build that consumer trust, take the friction out of the consumer journey so that we can switch that 5% participation metric to 95% participation.
The sort of vision here in the future is that electricity using devices sort of by default communicate with the grid. They just sort of built in. So we're heading toward a future in which basically everything electrical is networked. How close is that, do you think? What is our state of progress towards there, and how fast do you think we can get there?
I've seen a lot of positive change, especially in the last couple of years.
Yeah, it's been a crazy couple of years in this area particularly.
And one of the things that I can sort of pinpoint as a use case for this, or as a case study, is a growing number of car or EV manufacturers launching their own communication protocols or APIs.
Mm-hmm.
Up until not too long ago, majority of these were monitored and controlled through reverse engineered APIs. And there are players who specialize in that because that was the only way to communicate with these devices. But increasingly, these manufacturers are coming forward and saying, look, there's a better way of doing it. Here's our API. And we work closely with them as Kraken to say, we know what we want to get out of these devices. We know how to do this and collaborate with them in helping define how to design these. And that's something they do, how to operate them, and in some cases, how to commercialize them. And if we get this right, there's incredible amount of value for the manufacturer and the consumer in this. And that's the change that I've seen, that what was reverse engineered is increasingly becoming official APIs, which says there's a future in this connectivity.
Yeah. And as a kind of final question, to get back to this sort of VPP question or whatever we're calling these aggregations, you sort of work as a retail utility in areas with retail competition, like the UK and Texas, which has retail utility competition. What about areas without retail utility competition, where there's retail utility monopoly, basically? And so retail utilities are competing with other retail utilities and have strong incentive to lower costs for consumers, to trim, to be efficient. Sort of legendarily, monopoly utilities don't necessarily face those same incentives. In fact, they like spending money. It's how they make money. So are they biting on this? Do they want Kraken as well? Are you working with monopoly utilities? Are they installing Kraken?
Before I answer that, to put a clarification point, so Octopus Energy is in those countries, but Kraken, obviously, we work with competitors of Octopus, so we have to treat Octopus like another customer.
Right.
We operate in multiple more countries, and in often case, we work with what I call integrated utilities, where you have distribution, transmission, retail, and generation, as well as other competitive retailers like the ones in Texas. So Kraken is quite comfortable working with those utilities, but also appreciating, as you put it, their context is very different to a competitive one. They're not fighting for customers, but they're trying to run their systems more effectively. And as part of this electrification and also increase in renewable penetration, these utilities are having to run their systems differently. Their commissioners, their regulators are asking them to do that as well.
Yeah.
Therefore, I think they will continue having to invest a lot of money to enable the transition. But what Kraken allows them to do is help them better prioritize those investments. In certain cases, help defer those investments by getting more out of the existing infrastructure. To give you an example, we have what we call transformers deep in the distribution network, where a high voltage cable comes in and it gets distributed to multiple lines into homes.
Very difficult to get these days. Very difficult to buy these days.
Exactly. And that's one challenge. There's a big supply chain challenge, well put. But also, as you get more electric vehicles and heat pumps and rooftop solar, that's the part of your network that gets congested first.
Yeah.
So you could upgrade them, you could replace them, but that means supply chain issues, but also means public works. You need to dig the streets, which people don't like happening too often. So what Kraken allows you to do is both monitor the network in real time, sign up your customers to these intelligent tariffs that give them a benefit, cheap range or better economics in your home comfort, but gives the utility the ability to shift the behavior so that you're shifting loads away from peak times to allow you to use more of the capacity of the existing infrastructure and defer some of your capex to later years and avoid that costly financing cost and public works. So we're building use cases around the whole system running as opposed to operating better in competitive markets.
So you think there's no utility that couldn't put Kraken to use?
There's no utility that couldn't put Kraken to use. The first use case in North America is St. John Energy in New Brunswick. They're vertically integrated. They have distribution, retail, generation. They manage their own balancing responsibility, buying and selling of power.
Oh, interesting.
They are now implementing the full Kraken stack. It will help them deliver incredible customer service, get them to operate more effectively, and manage their what we call the peak load effectively so they reduce their costs. Everything I've just described could apply to a competitive utility, but a regulated one as well.
Right. And if Mercury is successful and Mercury certification becomes the industry norm, and thus Kraken can sort of by default incorporate new devices without this kind of bespoke work, what are the savings there? Is that going to save a lot of time and money for these utilities to have the devices sort of automatically ready? I'm trying to figure out sort of like how big of an impact is that going to have on this market?
So let me give you some metrics. And the capital deferral cost will vary by utility. So the two benefits you get, and depends on actually three benefits. But this will depend on your regulatory framework. So if you're in California, you will think about procuring electricity. But if you're in a vertically integrated utility, you'll have your own generation, and procurement is not part of your thought process. But if you were, it would be running your system more effectively, so achieving more from your grid and prioritizing the investments that you make. Second would be improving how you procure electricity, or running your system on greener electricity would be another way of describing it. And finally, delivering your consumers an incredible product that both they get savings from. So the kind of metrics we're looking at is reducing EV charging costs down to 2 to 3 cents per kilowatt per mile to drivers. That give them the clear, crisp reason to participate. And it could be 4 or 5, depending on where in the world you're in, but it's still a significant drop from the 30 or 40 cents that you would pay for your regular electricity. And then allowing your employees to have such a great product that they're happy to be working for you.
What a thought in the tech world these days. Devrim Celal, Kraken, thank you so much for coming on and walking us through this. I'm so interested to follow the development of this in the next few years.
Thank you, David. It's been a pleasure and fun.
Thank you for listening to Volts. It takes a village to make this podcast work. Shout out especially to my super producer, Kyle McDonald, who makes me and my guests sound smart every week. And it is all supported entirely by listeners like you. So if you value conversations like this, please consider joining our community of paid subscribers at volts.wtf, or leaving a nice review, or telling a friend about Volts, or all three. Thanks so much, and I'll see you next time.